Thank you, Dwayne. Dwayne asked me to do this. This is my first ever seminar, so if I mess up too bad, just bear with me. Mainly, we are out in the cornfields of Indiana, 2 hours south of Indianapolis, and kind of became a passion of mine. We was doing automotive repair for like 10 years, and kind of got bored with it. I'm always into trying new things, finding out where the weak links are on things, and so I came up with the first Duramax aftermarket head. Went to Brodex, got my own core box built, had Brodex doing some castings. Since then, we've moved in over to Granger Worland. We was having some issues with castings, just not strong enough. The differences, and this is what main thing Dwayne was wanting me to point out, there's a lot of differences between building gas engines and building diesel engines that are like 3,000 horsepower. You find weak links that you never dream that you find on gas engines, and diesel engines completely different. Boost levels are, on most of ours, they range up in the 100, 150 pounds of boost, and we break parts, tear parts up that gas guys never do, you know. So we're trying to write the rule book on diesel performance, and there's a lot of unknowns yet. We're still a young company, we're learning every day. Hopefully with the help of a lot of the professionals around here, we've got several of them, Dwayne, James, Comp Cam, Son and Bob, all these guys help us all the time. We find little things that we have trouble, so we go look for answers. But back to the cylinder head castings, get this to, okay, so starting off with the pulling trucks is where we started with performance engines, and mainly because that's our biggest market in this area is pulling. Drag racing starting to catch up with it, but right now we have super stock engines. Duramaxes mainly, we do a lot of Cummins stuff too, but Duramax is up in the 3,000 horsepower mark. So to get an engine that's designed for 300 to 360 horse from the factory up to 3,000 horse is a nightmare. We've found about every limit. We basically take a GM block, or have been taking GM blocks, putting deck plates on them, sleeving them, building girdles, building front and rear billet covers, billet cylinder heads on this particular truck. We have one on display over here, over on the right-hand table over here. But then stepping them down to more of the average builds are, I call them average builds. A lot of guys kind of laugh at us whenever we say that, but most of the engines that we're putting out the door are street-driven trucks around 1,000 to 1,500 horsepower. So they still tear up parts, but they live there too. A lot of 1,000 horsepower trucks will live for 100,000 miles. It just all depends on tuning and the driver behind the wheel. And then we have drag race engines also that we're building. And again, we're learning every step of the way. We have a brand new deal that we've came out with this spring with a shop truck. They have an ultimate call-out challenge that they called out 30 of the top diesel builders in the country and Canada. And we take the same truck and turn it from a drag race to a pulling truck and a dyno truck. So this is the picture of ours, and you can see the black smoke. We're definitely not tuned in yet, but we're getting there. But again, their drag races goes from 3,000 horsepower engines all the way down to the street ones that run every day at 1,000 to 1,200 horse. But basically on that particular truck, we started off deck plating engines. Now we've went to a complete billet block. We designed a mono block. So the center section on your left here houses the cam bearings, the lifters, and the upper section of the main bearing. You can see it in the center. We use Darton sleeves, the ARP top fuel head studs that go all the way through. And the main reason I did that is because we run into these things will try to lift the cylinder heads right off the block. And we just had it happen to a couple customers this weekend. One customer in Texas blew a Cummins completely in half. The block separated in the jug area, and the cylinder head and the turbos lifted up out of the truck and demolished the truck. But So we're running a top fuel head stud all the way from the top of the head all the way down into the jug, or down into the base plate, the center section of the block. So over on the right, it's part of the machining process there, but we're putting 4 sleeves down in a jug, and mainly the big reason for that is back to the guys that go out there and push the limits every weekend. They can have a spare set of those cylinder jugs in the trailer and build it there at the track. So instead of having to lay out the weekend or push us the next week to get them another block done, we're trying to get it to a point where we can send them extra parts. They build them right there at the track. So it's not preferred, but it happens all the time. And on the cylinder heads, on the left, we start off with our aftermarket casting, and it's good for most of the street-driven stuff, some of the performance. We run into an issue in diesel. They build so much temperature that almost any material has issues. The aluminum on these particular ones, where like the glow plugs come into the cylinder, they'll split across the glow plug area into the seats. We've got a lot of things fixed on the issues, but there's still guys that'll build so much temperature and pressure. So we moved over to the center picture. We take the same core box design, and we had to build a new core box for ductile iron, but now we're building Duramax cylinder heads out of ductile iron with no valve seats and no guides. So basically the seats machined into the ductile iron, and the guides are machined and finished right there in the cylinder head. And the reason for that is seats falling out of diesels with all the temperature. It seems like no matter what press, no matter what technique you've tried, and guys have tried about everything, they will fall out of on the high horsepower stuff. And then on the very far right picture is a picture of a 12 valve common rail head. So we developed this past year we developed a cylinder head for the Cummins guys that are wanting to run a 12 valve and bringing it up to the newer technology with the Bosch ECU and running Iveco injectors and everything. So that head's actually aluminum, and the only way that we've found to get those to hold is aluminum cylinder head with valve seats. Always want to melt the aluminum around the valve seats. So if you look at the head that we have on display, we came up with a design that have a ductile iron insert. It's like a big 4.6 diameter ring, 900 thousandths thick, and we press it up in the combustion area and do the same thing. We machine the valve seats and everything into that ring. The fire ring is machined onto the receiver groove is machined onto the cylinder, or on that ductile ring, and everything is locked into place. So far that's been the only way that we can run billet aluminum heads to make them hold. We've tried valve seats, and other companies have told us that valve seats should work. We still haven't seen it in the diesel performance. The gas guys, they run so much cooler and not as much pressures, so we have to kind of think outside the box to get it to work. We bought out R&R connecting rods 2 years ago, and on the steel side, all the steel rods, we purchased that. So all of our forgings are coming out of Trenton, Michigan, using mainly the forgings for just diesel related. We haven't got into the gas parts too much right now. Cummins on the left, we've kind of ramped it up. Most of all of our rods have the tongue and groove from the cap to the body, just so that keeps the rods from the cap walking on the rod itself. Using the ARP hardware, the 625 bolts to hold those in. Centers are Duramax, same thing. We're moving towards the tongue and groove on that one also, on the cap itself. And then the far right is the Ford. Starts off with the 6-liter 6.4s and the 6.7s. So mainly coming to Callies to give the presentation, and wanted to talk a lot about working with Callies on doing a new design crankshaft in the Duramax world. Basically, we've was doing this for some time now. We took the crank and narrowed the rod journals so we get as most material in the rod or the crank itself, and getting rid of the radius, the sharp radius, as a factory one has in the fillet area. But since then, Callies came aboard, and we was working with Windberg years ago for the last 4 or 5 years on the performance side, but now Callies has stepped in and helping us out on the street builds. There's a lot more street builds, and trying to get them to do all the stuff that we've been doing for the last several years, and it's definitely working. Dwayne, we've worked back and forth with him quite a bit, some of the guys in the shop, but had to do a double keyway on the snout. He's definitely made it a lot easier to internally balance it with the counterweight designs, and gun drilled it down through the center. But the end result has been really well, and we're putting kits together now with rotating assemblies, so you guys don't have to go out and pick parts off the shelf and try to make everything work together. I get so many phone calls from shops they're new to the diesel market, and they want to know what works with what and what clearances you do, and what, everything is new to them. So I'm trying to make it to a point where if we can supply a full rotating assembly and even blocks that are prepped to what we've found works the best, that way it's easier on the shop, the engine builders. So, but on the right hand side we do the billet caps, and the main, it's a girdle that goes on the bottom side of the block, and ARP we supply it as a full kit with the mains, girdle, and ARP 1/2 inch longer studs, and it just ties the bottom end together. We see a lot less main cap walk on that setup. And then to go along with the picture is kind of hard to see on the left, but to go along with the rotating assembly, we done some testing with flood dampener back here. Ivan, he helped us out, hooked us up on it, but we kept on having issues with a lot of the O-rings on a different supplier's dampers, and could not come up with a fix for it. So we would spit the rubbers at higher RPMs. It'd spit the rubbers right out of the back of the damper, and the harmonics was something fierce. You could feel it in the concrete floor at the dyno. There's about 4 different points when you could feel it really pretty serious on it. So done some testing, and flood dampers came out with a 0 balance to go along with the Callies crankshaft, and then we're supplying the rods and the pistons for that whole kit. So these are the rotating assemblies we're putting together. There's not a picture of it, but the street kit is with a Comp Star crank, so it's more of a street. We're rating it at 800 horse. I'm sure it can go up to 1,000 to 1,200, but we're keeping the ratings down on the kit. But it comes with the same assembly. So it starts off as economy kit, or like a starting kit, street, Comp Star crank, our rods, Molly, standard piston, the camshaft, wrist pins, balancer, and flywheel, and then it goes on up to the race kit. We are supplying all the race kits right now with the Ross pistons. We've found that the Ross pistons are holding the best with our application. We also use Diamonds, several other companies out there that are making good pistons. We've just kind of came up with this kit, and it's worked really well using the Total Seal ring package. A lot of the customers are definitely running into different issues with rings, but we've found AP stainless rings work really well up to a certain point in the power levels and the heat, and then we move on up to the M2 tool steel rings. But again, that's every tuner has its different setup. Everybody's a little bit different on piston to wall clearance. There's a lot of variables there, and that's what we're trying to narrow down with all these kits, is trying to make it easier for the engine builders to be able to go out and build one and not have to spend thousands and thousands of dollars trying to figure it out, because we've been down that headache. It's a long road to figure out what works with what, and we're still learning, but narrowing it down to all these kits we know that work on most of the setups. We got a shop truck that I was telling you about. We put a screw blower, twin turbos, and took it out this year for a lot of testing. And now we've actually trimmed it down. We found out with the PSI screw blower, it's actually performing better right now with that than with the combination. So we're going to SEMA with another PSI screw blower on our Billet DX500 in a drag car application. So we'll be out there. If you guys stop by the Premier Performance booth, we'll have it on display. So